I hope you can all hear me. So my name is Amir, and I work at Docker, and I worked on a number of different things while I've been there. So one of the things I was primarily working on was the unikernel technology, and I actually spoke here last year about that. And I was also involved in the early stages of Docker desktops, and that's something I'm going to talk to you about today. So first off is a thank you to everyone who's ever contributed to open source software. So hands up, anyone who's contributed to open source. You're all awesome people, because a lot of what Docker does is open source software, and contributions come from all over the world. So it's because of those people contributing to the code, sharing what they've done, that people like me get to stand up and talk about it. So here's what I'm going to be talking about today. So I'm going to cover the Moby project and how that relates to the Docker platform. Then I'll talk about what the components of Docker for Mac are. So can I get a quick show of hands who's used Docker before? That's a lot of you. How many of you have used Docker for Mac? Okay, nearly all of you. That's good. I'll be talking about the components that go into that. And part of that will be an introduction to a project called LinuxKit. How many of you are familiar with or have ever heard of LinuxKit? Fewer. Okay, that's useful. And then the point of showing you all that is to essentially get you to the point where you can build your own version of Docker for Mac. So as I said, all this stuff is open source software. So in principle, you should be able to take the open source stuff, put it together with a bunch of configuration, and essentially get much of the same product at the other end. Of course, it won't be quite the same, but we'll see how far we can get. And then I'm interested in having questions and a discussion with you guys. So please do post questions on Slido as you go. So the first thing is Moby and Docker. Now, how many of you heard the announcement last year about Moby project? Like 2 of you. So Docker is an open source. Docker is a company that works in open source software, and for a long time, the open source software was all under the trademark, the name of Docker. And then that started to get a little bit tricky to deal with, because people involved in the open source community have certain things they want to achieve, certain directions they want to take components in, that doesn't necessarily sit well with the opinionated stack of software that Docker, the company, wants to ship to its customers. And so last year, Solomon, the founder of the project, announced a separation in what was going on in terms of upstream work and downstream product. So upstream projects now live under the Moby project umbrella. So that's where all the open source stuff happens, and there's now a technical steering committee that looks after those projects. And then the downstream products are what Docker Incorporated, the company, puts together, adds configuration, bakes in all its opinions, and then ships and sells that to customers. And this is kind of what it looks like. So the upstream open source components, and this is just some of them, there are many more than this, they comprise all the bits that other companies can choose to use, can incorporate into their products. For example, Containerd is something that was donated to the Cloud Native Computing Foundation. Notary, another one there mentioned on the bottom left, was recently accepted as well by the Cloud Native Computing Foundation. So Moby project is not a foundation, it's a collection of projects that other people can come along and use and create their own container-based systems with. So if we look at that upstream-downstream split in terms of what it means for Docker as a company, here's one way of looking at it. So above that dotted line is all the upstream projects, the open source repos that comprise Moby project, and then downstream of that is all the stuff that we will call as part of the Docker platform. This is where all Docker's opinions get baked in. And down there on the bottom is Docker for Mac, because that is where all the opinions about how we should do container-based software development on your Mac is baked into. So what I'm going to show you today is how do we get from all that open source stuff into the actual product that gets shipped. So first off is a quick look at all the stuff that's relevant to Docker for Mac that's on the open source side. So these are the upstream projects. One chief among those is LinuxKit. There's also VPNKit and HyperKit. There's also DataKit, which I didn't mention there, and there's several others as well. And one of the reasons that I find this quite interesting is because there is also a bunch of unikernel technology that is baked into some of the projects that are upstream. How many of you heard of unikernels? Okay, few of you. There may be a video from last year's talk. And of course, there's other stuff as well. There's not just those components. There's also a GUI, and there's also like stuff with the CLI and a bunch of other things that go on. So let's focus on one of those to start with. Let's look at LinuxKit. This is cutting out slightly, so it may be the battery. So let's look at LinuxKit in a little bit more detail. So for those of you who are not familiar with this should be useful. So LinuxKit is essentially a component for building container operating systems. So if we take a step back and think about what is it that Docker for Mac actually has to do. So that stack on the right is roughly, it's a fairly rough diagram to give you an idea of what it's like trying to get containers running, with Linux containers running on Mac OS. You have the underlying host, which is Mac OS. That ships with something called hypervisor.framework. So it has a native hypervisor. On that hypervisor, you want to run a virtual machine, a VM. In that virtual machine, you want to run some kind of OS, a container OS, and then on top of that, you want to run your Linux containers, which you can just want to be able to pull from the hub. That's the stack. So Docker for Mac, that has to understand and be able to manage anything within that dotted line, which includes starting the VM, turning the VM off, dealing with disk, dealing with network, all of that stuff, and making that transparent to the user so that the user has a nice, pleasant experience, a native experience. So there's specific needs for that OS layer that we have in there. Obviously, it's got to be a container-based system. So it's got to be a container OS. But more than that, we want everything that runs there to be run as a container. We want that OS to be immutable. Security is a big concern, so we want to be as secure as it can be. Immutability helps with that. And we wanted to be able to make it as lean as possible. So nothing goes in that does not need to be there. So these are all the requirements that we needed for that kind of OS. So we built one. As we were building Docker for Mac, we ended up having to put together our own distro. And that initial distro wasn't actually intended to be released. It was meant to be wrapped up in part of the product. But what we realized was this is actually useful. The tools that we used to get there were actually quite useful. So we generalized those. So now it's possible to take the tool chain, and LinuxKit is essentially a tool chain and a collection of packages to help you build your own container OS. So you can produce something that the tool chain is highly customizable. You get to choose what goes into it. It's defined through YAML files, which means it's relatively straightforward to understand. And you can build your container OS in seconds. And so you can use this to build whatever kind of configuration that you need for your particular use case. And so this is very useful. So we use this to produce the OS that finds its way into Docker for Mac. And this is also something I can show you now in terms of how LinuxKit actually works. So now this is the part where I'm driving a terminal by looking over my shoulder. So please bear with me. So you can install LinuxKit by using Homebrew. So there's simply a tap on Homebrew. So the two commands on the slide I showed previously will allow you to install it. And we can look at what options are available. So you can see you can build an image based on a YAML file. You can do packages. The two commands that we're going to be using today are build and run. We're not going to do anything much more than that. So let's build the most minimal LinuxKit that we can, minimal OS that we can. So all it does is just have a terminal and nothing else. So there's a YAML file for this already. So there we go, and that's what it's look like. That's what it looks like. So you can see we define what kernel we're going to use at the top. We have a bunch of init stuff that happens to initialize, and then there's also what happens when the image is booted, and also the services that are going to run. You can see there's actually only one service there, which is Getty, and there is nothing else that's going to run there. So that's a very simple, immutable OS that doesn't really do very much, but it does give us an idea of how LinuxKit actually works. So let's build this. Yes, this is going to happen a lot. Thank you. I mean, I could cheat and copy paste, but that's boring. Something else I'm going to do is disable content trust. Don't do this at home. The reason I'm doing this is because this actually, what LinuxKit will automatically do by default is check certificates, because it pulls down images from Hub to do its build, and it will check the certificates and the signing of all those the signatures of all those images. For the purposes of this demo, we don't actually need to do that. And then give it the YAML file, and now we cross our fingers. So all the images I need are already here, and so it's extracted those images. It's now creating this OS image, and there it is. It's done. That took about less than 10 seconds. So we can look at the files that it created, and there's other files in there, and you can see the minimal init.rd image. So it's about 40 megabytes in size. And we can actually boot this as well. So if we use the same command, LinuxKit, except now we run, we are now booting into that OS. So in just a few seconds, we went from not having a kernel image, pulling everything together, and then booting straight into this, which, as you can see, doesn't do very much. Oh, what we can do is look at the containers that are running here. So this is running on containerd. So the commands are ctr. That's it. Only the container running Getty is there. And we can see the image that we're running in. And since this is a virtual machine, when I'm done with this, I have to power it off. So that's essentially what LinuxKit enables you to do. So it actually does quite a bit of the stuff that we need for a product like Docker for Mac. So that's all great. Let's go back to our slides. So let's give you a quick reminder of what you saw there. That's the YAML file on the right that you can see. So it's fairly short. It fits, the whole thing fits on the screen there. And that allowed us to build a very minimal OS. It's very specialized to that one use case and nothing else. It doesn't allow you to do anything else. So even the file system there is immutable. And it was actually really, really straightforward. That file is about 19 lines long. It took about less than 10 seconds to build, and the image is about 40 megabytes in size. So that gives you an idea of the kind of images you can create with this. So, and you can have multiple YAML files. You don't have to have everything in one. You can have different YAML files to specify different parts of the system, and then LinuxKit, the tool, will compose them all together. So let's go back to our schematic of how we get from upstream to downstream. So we've got LinuxKit. That tool is already available in open source. So what else do we need to be able to get to that magical thing on the bottom right? Well, we probably need some YAML files from somewhere that pull in the necessary components. And I'm obviously revealing too much here by showing you the names. And this also shows how upstream feeds into downstream. So all the tooling is upstream, but a bunch of the configuration and the decisions and the opinions as to what goes where and how things are put together, that's part of the product. And doing that, we should be able to produce an ISO. We should be able to produce an image that we can boot and run that can do most of what we think Docker for Mac should be able to do. So, at this point, we should be able to build our own. Who wants to have a go? One person. All right, so the aim is we want to build and run something I'm going to call a Franken Docker for Mac. Now, the reason I'm calling it a Franken Docker is because we're taking a bunch of components, we're going to glue them together, and then somehow breathe life into it, and then hope that it does what we expect it to do, which is to run Linux containers pulled from Hub. So you want to build this, and then we want to check that it runs by just pulling and running a standard image from Docker Hub. And then, because we live in the tech community, and I spend a lot of time in Silicon Valley, we can just do some stuff, and then suddenly at the end of it, there's going to be profit. So we need the YAML files. So where do we get those? Well, I happen to work at Docker, which means I happen to have access to a bunch of private repos. So I went poking around, and I found some. So I actually found 2 YAML files that are going to be relevant for what we need. This is based on YAML, and you can see at the top there, it defines which kernel image we're going to use, and it defines a bunch of other stuff. So for example, in the init at the top, you can see We're using VPN-Kit, runc, containerd. There's also stuff there about certificates, as well as all the stuff that's on boot. And this runs off the rest of the page. It's about 90 lines. There's also another YAML file, which defines which version of Docker we're pulling in. And so there's a bunch of extra stuff here as well. And I gave you a hint about these two files earlier. So what should we expect when we build this with LinuxKit? What is the actual outcome going to be like? So if you remember the diagram from earlier about what the stack looks like. So you have macOS. Then you have the hypervisor that's built into macOS. So what we're actually doing here is building a completely new, something that's going to launch in a new virtual machine image. It's going to have its own OS in it, and the containers are going to run on that OS. So if Docker for Mac is the stuff that's in red, the stuff we're building is going to be separated and off to the side in its own separate virtual machine environment. So let's have a go. So let's see how far we can get with that. We're going back to our terminal. I'm going to kill this. Right. Where am I? OK. So there are those two files, base and the Docker CE. So what we're actually doing now is we're going to take LinuxKit, and we're essentially just going to give it those YAML files with a bunch of extra configuration, and then essentially build an image. So I'm going to start with simple commands we used before. If you see me typo, please do say so. Thank you. I'm going to call it frankendoc. And I'm still going to disable content trust because I don't need to do certificate checking. I'm also going to specify what format I want the image to be in. So these are all configuration options that you can see by linking a LinuxKit help. So I want to produce an ISO image. And that's about it. Now I want to give it the two files. And so at this point, what should happen is it does work. All that is going to read Linux is going to read those YAML files. The images it would be pulling from Docker Hub because all the images for each of those components is pushed to Docker Hub already. But because I've pulled them locally to avoid hitting the network now, this build should be quicker. And this typically takes about 40 seconds to do. So the last stage of this is it's messing with it's messing with tarballs and packing things together, and that's why it takes a little bit longer. And so this is the point at which you would be putting your VC pitch deck together to say how you're going to come up with a startup that's going to take away all of Docker's revenue. And so when this is done, we are then going to take LinuxKit, and now then we would use the run command. So it's built. So let's have a look. So there it is. So you can see the ISO there. It's about 330 megs. And that's pulling in Docker CE. So that's why it's one of the reasons it's quite big. So Docker CE has a lot of stuff in it. But that's not enough. Now we have to run this and check that it actually works. Am I doing it again? I am doing it again. I'm really bad at this. I should just alias that. So we're going to run. And now I'm going to have extra commands to specify what I'm running it on. So LinuxKit needs to know a little bit more detail about what this image is and where I want to run it. So I want to tell it that I'm running it on HyperKit. And not only that, there's extra magic I now have to think about in terms of telling LinuxKit to set up a bunch of things around networking. Because we have to be able to talk to the containers that are in that virtual machine. And as I mentioned before, VPN-Kit is one of the projects that deals with networking. And so we already specified that and pulled it in. So we're just telling LinuxKit that we're using VPN-Kit for this. We also need to give it a disk so it has somewhere to store the states, otherwise it will crash. That should say size is 4 gigs. And there's also some arcane stuff about the mechanism by which we get information from within the container to outside. So I'm also going to specify vsoc ports. And there's still more stuff. So you may notice up there is a metadata.json file. In there is a little bit of information about how, that passes a little bit of information about how networking, that will be used by networking. So I'm just going to pass that in. Also, what kind of file it is, and then I'm going to give it the ISO. So what this should do now is boot that virtual machine image, turn on the OS that's in there, with all the networking set up properly, and then once that's done, we should be able to have something that can pull images from Hub. But before I do that, I'm actually going to turn off my local install of Docker for Mac. Not that it makes a difference yet. So let's see if this boots. See, blank screens are not good. There we go. So there we are. So we've booted into a virtual machine image. Now let's see what containers are actually running in this image, because everything runs as a container on this OS. So these are all the containers running. You can see the VPN kit forwarder that deals with passing information in and out. There's the Docker D4M, there's terminal. So all these bits and pieces are here. This is great. Now what we should do is try and figure out how do we pull something from Docker Hub down into this image. So let's go into another terminal window. While we're here, I can show you what that metadata file looks like, just in case you're curious. So this is an arcane leftover piece because we used 9p. So some of this stuff is going to change in time. So now what we want to do is be able to, so for the moment, just show you that Docker is not running. And in effect, what I need to do now is pull an image from Hub. But it's not enough to just pull from Hub, because I need to send that command into the OS so that it can do the pull from there. So that's what that command is. That's the socket that it's talking to. And I'm setting up the ports because I want to be able to look at that from the host machine here and then pull the image down. So that should... Ooh, I got something wrong. Is the daemon running? Yay for live demos. Oh, that's normal. Yeah. Right. Let's see if this one works. Okay, maybe this demo is not going to work. It was working 5 minutes ago. So I've turned my local Docker off. Oh, am I in the wrong place? Yeah. So there is more arcane stuff. And I'm going to explain this at the end of the talk. There we go. So now we're seeing what the Docker is running in that container. So the thing that I glossed over is that there's lots of magic going on here about how networking works in terms of things that are going on the host side and things that are happening in the OS and the containers. So now my command should work. So apologies for that. Cross fingers. OK, so what it's doing now is my OS that's on that we've just built is pulling down the Nginx container from Docker Hub, and none of this is happening with any of the native Docker for Mac. This is all happening with the stuff that we've just built during this talk. And so that download is complete, and because I typed the run command, so what I should be able to do now, because I set the ports up, so the -p 8080, I should be able to look at a browser window. And if I reload that page, we should be able to see that Nginx works. So this is the Nginx container that's running on that OS in the image, in the virtual machine that we built. And I do not have otherwise any form of Docker running on this machine at all. So we've gotten pretty far. We got as far as being able to run a bunch of commands using LinuxKit, and got as far as being able to pull an image from Hub into an image that we built using some fairly simple commands. But the thing, as you noticed, is I glossed over a lot of stuff. And there's lots of additional options needed to manage things like networking, to manage things like disk, and essentially telling LinuxKit what to do. And that's where some of the complexity arises. So we can get pretty far in terms of building your own version of Docker for Mac using all the open source tools. But there's a lot of extra magic that actually takes place as well that we also bake in. And so if we go back and look at this, we didn't actually complete this diagram. There is actually more that goes on in terms of configuration, where we pull in things like a GUI, we add in features that allow you to connect to Docker Hub securely with your ID, and also the additional work that happens with solving a bunch of the problems that some of which you saw now. And so this actually does give a neat example of how the open source work that happens in Moby project upstream finds its way into products like Docker for Mac, the packaged things that we ship that people download and use. And one of the nice benefits of having a pipeline like this is that any upstream work that happens on the open source components can also find its way into the final products. And that path is easier because that pathway already exists. One of those examples is Kubernetes. So Kubernetes support was added to LinuxKit in the open by community contributors and by people at Docker over many, many months. And it was only at the last DockerCon where we announced, in fact, a couple of months ago, where we announced that Docker products are now going to come with Kubernetes support. So, and it will be vanilla Kubernetes. It won't be a wrapped version or any additional configuration. It will just be the straight thing that you get from CNCF. And that's partly because of the work that happened upstream. So I'm going to pause there. I'm going to summarize now. So essentially, you can build your own version of the products that are downstream, because the upstream components are actually quite powerful. And so we find people using these to build their own versions of the OS that they need, their own container OSs, without having to do all that work themselves. And with having a community around that kind of project means that everyone benefits from the work that goes into it, and they still get to pull in their opinions and their own solutions towards the end. Of course, if you're just doing this is a useful thing to do for fun, to demonstrate that it's possible, and so you can learn about how the components fit together. But if you're doing that, but if you just want something that works, then we would say just use Docker for Mac, obviously, because there's a lot of work that's already taken place to fix edge cases and problems that people have reported. So all the files I pointed out are actually in public GitHub repositories. So if you wanted to go at the YAML files that I pointed out, you can find them in github.com/LinuxKit. There's a blueprints directory which gives examples of how to build certain OSs, how to build certain and there's also other examples you can look at how to build minimal OS images to run certain tasks. For example, there's a Redis OS YAML file which pulls something together to just run Redis and nothing else. And finally, there is also a Kubernetes beta that we're putting together. And if you're interested in running Kubernetes with Docker, then please register for that beta. So that beta is for both the Docker for Mac desktop product. So that's going to be the version that runs on here. You'll be able to run a single node Kubernetes. And also for Docker Enterprise, So that's the one-line pitch. I will actually stop there before. I know there's plenty of time left. So if you do have questions, I'm really interested. And if you're interested in just having a discussion about this stuff, I'm also curious.
Yeah,
Thanks.
We actually have some questions. Yeah, well, thank you. Thank you very much. Yeah, well, the question that get the most votes actually is about not about Mac, Docker for Mac, but Docker for Windows. How do you run Docker and VirtualBox on Windows 10 at the same time?
I think the short answer is you can't.
Well, I think you can, but you have to disable Hyper-V for that.
Yeah, you can't run them both at the same time,
Yeah.
as in simultaneously. I think you have to choose one or the other. And I think we've also had questions in the past about running on the Windows versions older than 10, and that's not something we can do yet.
Okay. Yeah, next question is, what are some typical business cases where Docker is the perfect solution?
Building an application. Do you really expect me to say something different? So if you're building applications for servers, Docker's very good for that. Putting anything in a container, if you're doing anything with containers, Docker will be a good solution to that. Because what we're trying to do is have an end-to-end platform from apps that you run on your desktop to do the development work, all the way through to the ops people who actually deploy things and then manage clusters. So that's what Docker intends to be good for. I hope that answered the question, but if not, come talk to me afterwards.
Okay, well, I think you mentioned that, but maybe you can reiterate. What is the difference between what you have shown us and the actual Docker for Mac? What is the value added?
Okay, so Docker for Mac does a bunch of additional stuff with the networking. So what we didn't see here is, what I did not show you was all the additional configuration that happens with things like VPN-Kit to give access to all the stuff that's going on inside. There isn't any GUI associated, so changing things would require you to rebuild everything I just showed you. Whereas with the GUI, we can do lots of extra things like change configuration, relaunch the virtual machine, and restart the containers that were there. So all of that stuff is built into the Docker for Mac product because it essentially makes all of that invisible to the developer. You don't need to worry about it.
Okay. Yeah. Next question is there any equivalent to LinuxKit from Microsoft Windows? Does it work on Windows?
I think I want to say yes.
Yeah. Yeah,
I think there is actually an example in the repository that uses Windows and Hyper-V.
Okay. Okay. The next question is this how Rancher OS is built?
There is a talk by someone who was at Rancher OS, and they have built Rancher OS using this method, and they've also done additional work to essentially prune the image down as well. So there's a talk I can point you at, which was at the last Moby project summit, where Sven Dowlett gave a talk on doing exactly that.
Okay. Yeah, and actually I have the last question. Do you think Mac will ever run Docker natively without virtualization layer? Because, I mean, you can run containers without virtualization on Linux, but Mac is kind of Linux distribution.
On Linux. And because what we're trying to do here is run a Linux container on an environment that the Linux container wasn't designed for. So it relies on namespaces that are in Linux. So you somehow have to get Linux running. So it may be an interesting academic exercise. I don't think it's necessarily practicable.
Yeah.
Because if someone has opinions on this, I'm curious to hear them. Because what we have now is actually allows us to just run straight Linux containers that you can pull from hub on this machine, on a Windows machine, on elsewhere. Yeah. And virtualization does play a role in that. Yeah,
but at the moment we have Windows native containers we can run on Windows hosts, right?
Yes.
And is Apple even interested in creating something similar for?
I have not had those conversations with Apple.
Okay. Yeah, I guess that's it from me. I have no more questions, and yeah, thank you very much.
There was a question.
Oh, well, there was one. Okay, sorry.
I just wanted to ask, is this approach, I think the answer will be no, but still, is this approach will help somehow to run this custom build Docker image on bare metal?
What about what?
So LinuxKit does allow you to build images that will boot on bare metal.
So
So LinuxKit allows you to target different things. So the example that I showed was being able to target HyperKit specifically. So booting on HyperKit. We do run instances on packet.net, which is essentially bare metal. So I think, yes, I think what you're asking is possible.
So I can build this on for bare metal and like run it on something like Raspberry Pi.
Yes. And there are examples where people have done that.
Yeah, there was one more question.
What's the story with Docker Swarm now in terms of like with Kubernetes being part of Docker? What happens to Swarm? And does that mean like Swarm will die?
So we support both. So they're both available for our customers. So essentially it's about choice. So we have customers who are already using Swarm. We have a bunch of customers who say they want to use Kubernetes, and now they choose which one they want to use. So they both matter, and they're both available. So it's just up to the customer which one they choose to use.
Is it going to belong to Docker eventually from Google?
Kubernetes is part. So the question was, is it going to belong to Docker? So Kubernetes is part of the CNCF. So it's already part of a foundation. And so it's not going to belong to anyone. It belongs to the community in that sense. So Docker also works with the CNCF on a number of things. So it's short answer to that question is no. Kubernetes is not going to belong to anyone. It already belongs to the community. Okay.
Any other questions? No? Well, then thank you. Thank you very much.
Okay. Thanks.